Welcome to Byjus exam prep, and I welcome all for this session, which is GATE Mathematics Special. And today's topic under this GATE Mathematics Special is Bayes Theorem. Okay, so welcome to this session. So let us start the class. You're all ready? Okay, today's topic is Bayes Theorem. Okay, so let us start with this. And myself, Sridhar Sir, I am having 20 plus years of teaching experience. My qualifications are M.Tech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad. I am associated with Byjus from past 1.5 years. We are working on this particular project called Recorded Gate Content. Okay. It's not just recording the gate videos, sir. We created visualized animated content for you. Under Byjus, hi, hello sir. Under Byjus exam prep app, learn with video lessons, you can find all these videos which were recorded by us. Okay. Many people are involved in this. Okay. And I created all these subject videos like engineering mathematics, and for computer science student, discrete mathematics, algorithms, C programming, data structures. Okay. So you can find these videos under Byjus exam prep app under the category learn with video lessons. So without wasting much of your time, let us dive into today's topic, and that is one of the important topic for GATE point of view in probability, that is, hello sir, Kaustubh, hi, Bayes theorem. But I will not directly start with Bayes theorem, sir. We will just take up 1 or 2 problems from yesterday's topic. Okay, make ourselves comfortable. Once people join, we start with the most important topic, and I'll try to make it as simple as possible with examples. I'll explain the complete story of total probability theorem and Bayes theorem for you. Am I clear? Sir, where to watch the continuous sequence of these subjects? See, my dear friends, under Byjus exam prep app, again I'll tell you the same story, where you can watch some of these videos in the sequence, my dear friends. At least 10 to 20% videos you can watch, my dear friends. Being mathematics is one of the important topic, you can watch more videos of that. Okay? And anyhow, we are coming up with these sessions on YouTube also. On app also we are coming up with many sessions. So for self-learners, we are trying to do as much as we can, my dear friends. See, on YouTube, that's what I am saying, sir. See, on YouTube, we are coming up with sessions. Am I clear? See, if you want quality, we have to wait for some time. We'll try to come up with all the sessions, sir. Some, marathon series and all we are planning, sir, for all these subjects. You can join my Telegram channel like t.me cs_Sridhar. You can tell me in that channel or in that group what topics you want to learn from me. Okay, so that I can come up with those topics, my dear friends. We are coming up with some, interesting series in near future. We are not in hurry, sir. So we go by a particular plan under Byjus exam prep app. So we come up with one very, very, very interesting series from next week. You will enjoy that particular series, I am telling you. One very, very important series called formula series from next week. Am I clear? That you will enjoy a lot. Then once you learn formula series, then we start with this marathon series where we try to take up some, crash kind of courses, right? Yeah, we'll come up with that, sir. Please join the Telegram groups which are given, where you will get the regular updates, my dear friends. Where you will get the regular updates. Am I clear? Here it's not a personal faculty giving the courses. A team will be there. The team will be involved, and we have a meeting. Almost we spend, sometimes 2 hours to 3 hours also in the meeting to design the series for you, my dear friends. Okay? So we'll come up with those series which helps you a lot. Believe me, the series which you are going to come up are useful for the people who want to revise, people who want to do self-study, and for everyone it will be useful. Okay? We don't just come up with some series of any sort, sir. We have a plan. Okay? We execute the plan. Just follow our Telegram groups, Byjus exam prep Telegram groups or individual Telegram groups, where you know about individual faculty classes, sessions, or series which he is taking, or otherwise from Byjus exam prep group also you will know this particular information, my dear friends. Right? Okay. So, yeah, yesterday I stopped with this problem. I asked you to solve it. Random variables, I am starting from Monday, sir. Monday's random variable, Tuesday, some probability distributions I take it. Monday, Tuesday, we'll conclude the probability with bang. Like, random variables we'll try to understand on Monday, and on Tuesday we'll take up some important distributions, my dear friends. So that would be about my probability series. As I promised, I take up all the sessions in a systematic order, my dear friends. Yeah, expectations, everything will be covered. Okay, I give you the idea what you need to know, and rest of the story is how you apply them. Right? Now, a two-faced fair coin has its faces designated as head and tail. This coin is tossed 3 times in succession to record the following outcomes. That is, you tossed it 3 times and you record these head as outcomes. Already people are answering very good, Vasu and Rahul. Superb. If the coin tossed one more time, the probability of obtaining heads again, given that the previous relations are head and head. See, my dear friend, it is a simple situation of independence events. See, when you get head in first 3 tosses, what is the probability of getting head in the 4th toss? The probability of getting head in the 4th toss does not depend on what happened in the previous tosses. So, it is same as probability of head when you toss a coin, and which is nothing but 1/2 because it is a fair coin. See, when you say fair, ya to unbiased, all the outcomes are equally likely. That means head probability and tail probability will be same. Whereas biased one or loaded one means they have to mention the probabilities which you can use and solve the problem. I'll give you one such problem also. Right? That's very good, sir. Very good. Super fast. Now this one. Please answer this question. This is a great question. See, today's topic would be very interesting. I'll give you the idea of Bayes theorem perfectly, sir. And what all variants you can get from Bayes theorem, I'll give you that. And it's all about your application, my dear friends. I'll give you the idea of Bayes theorem and total probability theorem. They are linked with each other perfectly. Wait for some time. And all variations will be covered. Lalit, see, you tossed a coin. Head you got. Again you tossed. Head you got. Again you tossed. Head you got. Now, when you toss 4th time, what is the probability of getting head now? What is probability of getting head now? Because the 4th coin or the 4th toss, when you toss the coin, the outcome does not depend on the previous tosses. Does it depend or does not depend? Does it depend or does not depend? Simply 1/2. That's it. That's it. That is what they done. Okay. This is a wonderful problem, sir. See, I'll tell you the variations which they asked in GATE also. They asked this question like this. The famous problem which you all like it. The famous problem which you all like it. From pack of 52 cards, you take a card. Replace it. Take a card. Replace it. Take a card. Replace it. Now, you've taken the card 4th time. You've taken the card 4th time. What is the probability that it is a king? This was a GATE question. Yes, the story is to confuse you only. Yeah. Story is to confuse you. So, what is the probability that it is head? I'm sorry, what is the probability that it is a king? What is the probability that it is king? Four by 52, because you replace now the previous draws does not affect the 4th draw. So it is probability of king is 4/52. See, to confuse you, he said in the previous draws what happened. Sometimes they also mention in the first draw I got a diamond, second draw I got a heart king. Like that they mention some story. Now people worry more about the stories than actual problem. That is the story. Am I clear? Hope you understand. So the answer for this problem is 1/2. Even that problem, card wala problem में भी answer क्या था? 4/52 था. Wonderful. Next question. Please answer this question, sir. The probability of getting a head in a single toss of a biased coin is 0.3. See, it is a biased coin. Replaced with the same card, not with 100 rupee note. See, taken and replaced, I mentioned the same card only. Right? Now, here this is a biased coin where the probability of head is, what is probability of head? I not given, he given. How much? 0.3. So, what is probability of tail? What is probability of tail? No, Lalit Yadav, you misunderstood the problem. What is probability of tail? 0.7. Probability of tail is 0.7. Now look here. The probability of getting head in a single toss of a biased coin is 0.3. The coin is tossed repeatedly till a head is obtained. That is, till you get head, you are tossing the coin. Toss the coin. You are doing this till you get head for the first time. If the tosses are independent, wonderful, biased coin, but the tosses are independent, obviously. Different tosses are generally independent, my friends. Then the probability of getting head for the first time in the fifth toss. What is probability of getting head for the first time in fifth toss? What is the probability of getting head for the first time in the fifth toss? This is the question, sir. Now look here, I'll write what is known as favorable situation. What you want. What is that you are looking for? You want to get head for the first time in fifth toss. Means totally how many tosses happened, sir? 5 tosses happened. In that, you want to get head for the first time here. That is, here you want to get head for the first time. Means, what happens in the first 4 draws? What happens in the first 4 draws? First 4 draws में क्या होगा? First 4 tosses में head नहीं होगा, यानी tail होगा. यानी you are looking for this particular event of getting tail in first toss, tail in second toss, tail in third toss, tail in fourth toss, and head in fifth toss. So this is what you are interested, my dear friends. Because they are independent, probability of A and B, you all know when A and B are independent, probability of A and B is simply probability of A into probability of B. Just write the probabilities, multiply, you will get the answer. What is probability of tail? See, here I am not saying that I want to get one head somewhere. I am not selecting head somewhere. I know where I am getting head. I know where I am getting head. Fifth time. It is not, selecting head anywhere. Because of that, Mr. Murali. Is that clear? So here it is. Don't write 1/2. It is a biased one. Probability of tail is what? 0.7. Probability of tail is what? 0.7. Tail is what? 0.7. Tail is what? 0.7. Head is what? 0.3. So what is the answer? 0.7 power 4 multiplied with 0.3. Bang on the solution. Got the solution? Perfect solution. Hope you understood. See, in mathematics, it's all about misunderstanding only, sir. People generally say, sir, I am getting confusion and all. That is your misunderstanding. Understand problems properly, you never do mistakes. Right? Very good, Kaustubh. Super. I like today Mukhopadhyaya answering million. 1 in million is also answering. See, if 1 in million can answer, all of us can answer. Next one. Answer this question, sir. It's a beautiful problem. This one is a beautiful problem. Gate question only. I just selected few gate questions so that you understand the categories or the variants which they generally ask in gate. A box contains 4 white and 3 red balls. In succession, 2 balls are randomly selected and removed from the box. 1 and 2. You done that. Given that the first removed ball is white, First one taken out is white. The probability that the second removed ball is red. What is the probability that the second removed ball is red? Are the events here are independent या dependent? ये dependent वाला problem है या independent वाला problem है? Yeah, we doing same thing. Today also almost we do the same thing, but conditional probability for future probabilities or the future events you are going to do it. Okay? Independent. See here, what is that he want? What is the probability that he get red in second draw, given that he get white in the first draw? Simple way of writing. Yeah, what is the answer for this, sir? See, my dear friends, so this is the situation. We have 4 white and 3 red balls. First draw you taken white. White is taken, so how many white remaining? 3 white remaining. Now given that white is removed, it is not replaced. What is the probability of drawing red from this box now? What is the probability of selecting red from this now? What is the probability of selecting red from this now? Now how many balls are there? 6. What is probability of selecting white ball? 3. 3 by 6 means what? 1 by 2 is the correct answer. Okay? I'll ask you one more question. Please answer this. Very good, very good. Mukhopadhyaya, Alpha, Beta, Yadav, Murali, super. Vasu also super. And Rahul Raj, you are rocking. Rocking, sir. See, I always tell students, at this age, you have speed. And I manage things with my experience. And you can beat my experience with your speed because your speed is 100 times faster than me. Okay? You have to believe in your speed and don't do mistakes, don't misunderstand. You can talk. Avoid mistakes, of course. This is the time where you do mistakes. This is the time where you do mistakes, of course. Once you do mistake, when you know it, immediately correct it. I generally say, dare to do mistakes, care to correct it. Distractions obviously happens for everyone, sir. Distractions, sometimes people create, sometimes we create. That's all part and parcel of the game. Let it be. See, when you know there is a distraction, means you know it, avoid it. If you don't know, then that is a problem. You know it. You are like a Baba. See, the people who know about something, they know something means that is a great thing, no? You know there is a distraction, avoid it, simple. Avoid distractions by yourself. No one is going to help you for that. Yeah, what is the answer for this? Very good. So when you remove first time, what happens? 4 white and 3 red are there. 1 is removed, so 2 red are there. So what will be the probability, sir? 2 by 6. So, white you want, white you want. I am sorry. See, I also doing mistakes. What is it? What you want? 4 by 6. Super. That's it. Very good. Next one. This is an interesting problem, sir. This is a very interesting, important type of variant, sir. This is what we call it as dependent event problem. Please solve this. Please solve this problem carefully. Please solve this problem carefully. So generally I tell people, motivations, okay, you can get it, but you should be self-motivated. Okay, I can give guidance for, solving problems. For motivation, it will not be the same. For problem motivation, I can tell you, because for everyone solution is the same. That is easier. Whereas motivating students, motivating different varieties of students is very dangerous job. Okay. There are some experts, let them do it, okay. I am expert in this. What is not clear, you Naveen? Or this problem is not clear, or previous one? Yeah, let me explain this problem. Naveen, see this carefully. A bag contains 4 white and 6 green balls. Don't worry, I'll solve it. I'll tell you. Balls are drawn at random, one after the other, without replacement. You take and throw it. Don't replace it. Now the question is, what is probability of getting white ball in the second draw? What is the probability of getting white ball in the second draw? This is the question. So he's asking, what is probability of selecting white ball in the second draw? Now please tell me, the probability of selecting white ball, that is selection of white ball is an event, no? That event depends on the previous event or not? That is second draw, you want to get white ball, no? Does it depend on the previous draw or not? Dependent or independent? Does it depend on the previous draw or not? Depends or not? It has to depend, no? Because in the first draw you taken out something and you not replaced. If it is white, the answer is different. If it is red, the answer will be different. So it depends. First draw, what happened, that affects second draw. The second draw is affected by first draw. Am I clear? So let me understand this favorable situation, my dear friends. What is that you are looking for? Of course, we are having 2 draws, first draw and second draw. What is fixed here? Here you want white. Second draw you want white, that is fixed. But in the first draw what happens? Is it fixed? First draw what happens? Is it fixed? Replacement will do. I'll tell you after this. First let us complete it. Let us not confuse. We are not without replacement it is. First draw, is it fixed? First draw is having 2 choices. It can be white or red. So the second draw you want white, it may happen in 2 cases. Second draw you want white, it happens in 2 cases. In the first draw, white may happen, or in the first draw, green may happen. So we have to see these 2 situations. So the favorable situation does not happen in a single way, it happens in 2 disjoint ways. It happens in 2 different ways. So we need to answer for both, and collectively that will be the solution for your problem. That is, probability of getting white in the second draw happens in these 2 favorable cases. Okay, so now what about this? Now let me show you first situation. We are having 4 white and 6 green, sir. What is probability of selecting white in the first draw? What is probability of selecting white in the first draw? Because total 10 fellows are there. How many white? 4 are there. And you are removing it but not replacing it. It is without replacement. Taking it and throw it somewhere. Now, what about probability of selecting white now? When you select white ball, what is probability of selecting white now? The probability of selecting white now would be 3 by now. This is when in the first draw you are having white, or you draw white. Now, second situation. Again see the situation carefully. We have 4 white and 6 green. What is probability of selecting green in the first draw? Green in the first draw means 6 favorable out of 10. 1 fellow is removed, we have only 5 green. Now what is probability of selecting white in the second draw? What is the probability of selecting white in the second draw? White means 4 favorable out of 9. And that is the answer. So what is the denominator, sir? 10 into 9, 90. Numerator 12 plus 24. Correct or not? 12 plus 24. 36 by 90. And that is nothing but 2 by 5. Very good, sir. 2 by 5 means 0.4. Super. Only 0.44, 0.4 million. Dear million, it is 0.4, sir. Don't mess up. Exact. Oi, Rahul Raj. What is 0, 0, Rahul Raj? What is that 0, sir? 0.4. Okay. Printing errors. It happens in my classes regularly. I also do the same thing. Okay. Good. Super. This is one more very interesting problem, sir. Very regularly they ask this question in interviews, in puzzles, or in interviews, not in gate kind of any kind of interviews also, it is a very regular question which they ask. Okay, suppose you are going for placements and all, there also this is a very common question which they ask. One of the interesting important question. Same kind of story. Those who understand previous problem, this is also similar to that. For me, both problems are similar, sir. This one and previous one are similar for me. Answer. Hope you all know about cards. Very good, sir. But Lalit, that is wrong answer. Now let me tell you, hope you all know about cards, right? This is spade, 13 cards are there. This is club, 13 cards are there. Then we have this fellow called diamond and heart. Correct? Each 13 in number. 13, 13, 13, 13. And in each shoot, we are having ace, number 2 to 10, king, jack, queen, or jack, queen and king. This is the situation, we know it. So in the shuffled card, or well shuffled pack of 52 cards, we are having this 52 cards. Now what is that? We are taking cards one after the other without replacement. We are taking cards from this shuffled cards, we are taking first draw and we are taking second draw. See here, the probability that the first card being heart and second card being red king. So we want probability for this particular event. So let us see the favorable situation, my dear friends. Let us see the favorable situation. See, we are trying to see what we want. That is what you mean by favorable situation. See, first card you want heart and in the second card you want red king. Now please tell me, are they disjoint or there is something common between them? Are they dependent? It's not disjoint, it's actually. Are they dependent or not dependent? This heart affects this red king or not? Heart affects the red king or not? Because in heart there is a red king. In heart there is a red king. So in the first draw, whether you take in heart which is a king or heart which is not a king, it affects the second draw, my dear friends. It affects the second draw, my dear friends. Because first card which is drawn is a heart. Heart is also a red card which can be a king also. That means a red king may be already selected or a red king may be not selected. Second draw depends on that. The second draw depends on that. Am I clear? So we want red king in the second draw, that is fixed. Red king in the second draw is fixed. We want that anyhow. But it depends on what happened in the first draw. In the first draw, you want red king in the second draw, this is fixed for you. But in the first draw, it may be heart king, or it may be heart which is not a king. Based on that, you get red king in the second draw. So based on this, the second draw answer will be dependent. Now here you see we are having 52 cards. We are having 52 cards. In that red cards are what, sir? Red cards will be 26. In that, first one you want heart. So I'll tell you what are these heart, how many are there? 13. Red cards are 26. In that 26, 13 are hearts only. But here it is not about heart and red, sir. It is about kings. You want red king. Red king, how many are there? Red king, how many are there? 2 are there. In that, one is here and one is other one. Am I clear? So we need to understand that point carefully, my dear friends. Now I will remove this. Now let us see. What is probability of selecting a heart king? How many heart kings are there? How many kings are having heart? How many kings are having heart? There is only one king with heart out of 52, sir. Because first draw you are selecting a king with heart. There is only one king with heart. 1 out of 52. So one card is removed, thrown out. Now how many cards are there? 51. Here already one red card is gone. How many red cards are remaining? See, out of 2, 1 is already gone because you selected Heart King. 1 is gone, only 1 is remaining. So that can be selected in one way. Out of remaining 51. Out of remaining 51. And in the second case, red kings are 2 and hearts are there. First draw heart which is not a king. Heart which is not a king. See, actually this is selected means this is gone. Heart which is not a king. So we are selecting from this. We are selecting from this. That means 12 out of 52 is selected. That is, one of these 12 cards out of 52 is selected. Now what happened? These 2 cards are still alive because you not selected red king. So how many ways you can select red king, my dear friend? Because now one card is gone, 51 remaining. You can select red king in 2 ways, my dear friends. So the answer for this problem would be this, my dear friends. So many people are giving different answers, but answer for this problem is this. So what is the answer for this? Denominator would be 52 into 51. Numerator 1 plus 24, that is 25. So this is the answer, sir. Use calculator to simplify that, my dear friends. Use calculator to simplify that. Is the idea clear? Of course, I don't need this. Now I move on to the next topic, that is total probability and total probability theorem also people call it, and Bayes theorem. See, here the situation is simple, sir. We are having some events which are happening. Let us say event 1 and event 2. Following these events, there is one more event which is happening. This is extra event which is happening. Let us call it as some A. So here originally we will have event 1 which is having some probability, event 2 which is having some probability, which are known as priories. Priori probabilities means known before. They are known before, well known. Now, following these events, another event A is happening. Following these events, A is happening. So, when A is happening following E1 and E2, we can find what is probability of A when E1 is happened. We can find probability of A when E2 is happened. We call them as conditional probabilities. What we can find? Conditional probabilities you can find. And we generally call them as likelihoods. What are these called? Likelihoods. That is, how likely that A happens following this event E1 and E2. How likely that event A happens given E1 and E2, my dear friends. So, event E1 is there, event E2 is there. Following that, another event A is happening, sir. So, in such situations, what they'll ask you is, what is probability of A? This is what is called total probability. Because A can happen following E1, following E2 also. They'll ask you what is probability of A. So, probability of A means after E1 A can happen or after E2 A can happen. So, we find probability of A using this multiplication result, my dear friends. And for multiplication, we have simple formula like, probability of E1 into probability of A given E1. And for this, probability of E2 into probability of A when E2 is already happened. So, this is what we call it as total probability, my dear friends. So, whenever an event is happening following other events, probability of that event is given by probability of first event into probability of this event when the first event is happened, or probability of the second event into probability of this event when the second event is happened. And it can be generalized to any number of events, my dear friends. It can be generalized in any manner, my dear friends. That is what we call it as total probability. And if you want to find total probability, it's very, very simple, sir. They can also write this in tree diagram. The same thing they express in tree diagram. E1, E2 are happening. Following this, an event A is happening. In this particular case, what is probability of A? If you can arrange the probabilities like this, you don't even have to worry about this formula, sir. This is a formula. You don't even have to worry about the formula. You arrange them. E1, A given E1. E2, A given E2. Suppose there is something like E3, A given E3. Like that, if you arrange them, just multiply the corresponding probabilities and add, you get total probability, my dear friends. You get total probability, my dear friends. Okay? This was a simple question. Using this question, I'll explain the idea of total probability and Bayes theorem. Both will be explained with this example only. This example will give you the complete clarity of this gives you the complete clarity of total probability as well as Bayes theorem. Okay? Yeah, this CS underscore Sridhar. This is the link for all the general students, my dear friends. For all the YouTube students, this is the Telegram group which I am using, CS underscore Sridhar, because I can share the information about mathematics as well as computer science. Okay? Yeah, I'll explain. Now look at this. Look at this problem, my dear friends. The probability that students know the correct answer to a multiple choice question is 3 by 5. Don't worry, sir, without formula I'll tell you how to solve it. I'll tell you how to solve. Please hear carefully. Next 10 minutes is very important. Next 10 minutes, very important. Don't deviate here and there. Okay? Don't worry about, see, most of the people do this. Immediately writing, they want to write gate examination. It won't happen like that. There are some concepts which takes time to understand. Take that much time. Then once you understand, you play with these problems. So I'll give you this idea properly. Hear carefully. Don't deviate for next 10 minutes. Hear carefully. With this example, I'll give you the complete idea. The probability that a student knows correct answer to a multiple choice question is 3 by 5. He just given that. We need to understand, okay, probability that the student knows a answer is 3 by 5. See, it's like, before going for your examination, in your house also they'll ask how much you prepared. You tell your father or your mother, you say no, 90%, 100% you say. After going out also your friends ask how much you prepared. 1 chapter, 2 chapter you tell no. So that is what you mean by probability that you know. How much you know. How much you know is that. Am I clear? So assume that probability that a student knows answer to a particular question is 3 by 5. I say 3 by 5. 0.6, 60% he knows. So he knows 60%. If the student does not know the answer, then student guesses the answer. So if he does not know, he guesses the answer. See, my dear friend, in real world the situation is different. If he does not know, he guesses. Even if he cannot guess, there is one more possibility, like he copy. Okay? But we are not getting into all that real world stuff, sir. We are restricted to the information given in the problem. Here, we have only 2 choices. Either he knows or he guesses. Either he knows or he guesses. Am I clear? So, it's like this. He knows 60%, remaining he is going to guess. So, what is probability that he knows, sir? What is probability that he knows? 3 by 5. 3 by 5 means? See, that is different story, sir. 3 by 5. So, what is probability that he guess? Because either he should know or he should guess according to the given information. So, the probability that he guess would be 2 by 5, my dear friends. Probability that he guess would be 2 by 5. Now, this is before examination. Now, once examination is conducted, see the situation. He knows or he guesses. Now, what happens? For the question, either he knows or he guesses, there is one option of getting a correct answer. There is a surprise event, getting a correct answer. Now, please tell me, what is probability of getting a correct answer when he know it? What is probability of getting correct answer when he know it? See, don't write the answer, sir. Please hear carefully. Okay? It's not about answer. Answer we can do it. They are all Lilliputians. We can do it. But if you don't understand, even Lilliput problem will trouble you a lot. Remember, what is the probability that he get the correct answer when you know it? Arey yaar, if you know it, what is the probability that you get correct answer? If you know something, what is the probability that you get correct answer? 1, no. Theoretically it should be 1. Practically it varies. Because sometimes you know some answer, you put the answer and you see your friend. He says, so you write A answer which is correct and you see your friend. He says, you don't believe yourself, you write B answer. So that is practical situation, we are not getting into it. Theoretically, if you know what is probability that you get the correct answer, it is 1. Okay, so like that. Now what is probability that he get correct answer when he guess it? And for that you don't have to worry about it. He given the probability that the guessed answer being correct is 1 by 4. Probability that the guessed answer is correct is 1 by 4. See, he may say like this, or he may say that each question is having 4 options. Each question is having 4 options, he can say. If each question is having 4 options, multiple choice question, what is probability that it is being correct, sir? Probability of that it is being correct is, the guessed one should be correct answer. So 1 out of 4. Like that also you can take. And you don't have to worry about it because he clearly mentioned. This is the information given to you. Means, these are the priori probabilities before going for the examination. This is likelihoods, how likely you are going to get the correct answer. How likely you are going to get the correct answer. Now, what is probability that you get a correct answer? This is what we call it as total probability. What is the probability that you get a correct answer? See, I will tell you the same thing as a tree diagram now. I will tell you the same thing as a tree diagram. Once again, see this carefully. Either student know or he guesses. Probability of knowing is 3 by 5. Probability of guessing is 2 by 5. Following this, what is happening? He is getting correct answer when he know it. He is getting correct answer when he guesses it. What is probability that he get correct answer when he know it? It is 1. What is the probability that he get correct answer when he guess? Which is 1 by 4. If you can arrange priori probabilities and likelihoods in this order like this, if we ask the question, what is probability that he get correct answer? This is your total probability, my dear friends. This is your total probability. This is your total probability. What is probability that you get correct answer? How he can get the correct answer, sir? He know and give the correct answer? Know and give the correct answer? Or he guess and give the correct answer? That is 3 by 5 into 1 plus 2 by 5 into 1 by 4. Many people are already answering this, but I want you to understand this picture, my dear friends. I want you to understand this picture. So what is the answer for this, sir? What is the answer for this? What is the answer for this? 4 by 4, you can do it. So that denominator is 20. 3 4 12, 12 plus 2, 14. 14 by 20, yani 7 by 10, yani 0.7. So what is the probability that he get the correct answer is 0.7, my dear friends. Yeah, you can use any method, sir. It's all about understanding, my dear friends. See, the idea which I want you to understand here is, see here, he know, he guess. Sometimes you also may have something like he copy. He copy. In that particular case, again it continues. Copy, let us write it as copy CO, let us write it, because otherwise CC, there will be some confusion. Copy. He get the correct answer when he know it. He get the correct answer when he guess it. He get the correct answer when he copy. Even here the story is same. What is probability that he get the correct answer? K into C given K, that is he know and get the correct answer, he guess and get the correct answer, or he copy and get the correct answer, or something like this. He pray God, and what is probability that he get correct answer when he pray God? See, it's all about how you can interpret, my dear friend. you do recursively, sir? It's not recursion which is happening here. It's not the recursion which is happening here. It's not recursion. Am I clear? Because the problems must be depending on each other. That is a part of this, that should be a part. It's not recursion. So don't unnecessarily get into trouble, my dear friends, doing over interpretations. So that would be the answer. That would be the answer, my dear friends. Am I clear? So what is it? Probability of K into C given K, probability of G into C given G, probability of CO into C given CO, probability of P into P means Pray-God. Okay, like that. Is the idea clear? So whenever you are interested in total probability theorem, the formula also goes like this. We are having events like B1, B2, B3 and so on. Following this, there is another event A is happening. Following this, another event A is happening. Then they will ask you what is probability of. Then they will ask you what is probability of A. Then they will ask you what is probability of A. And it is simply corresponding probabilities you multiply. Corresponding probabilities you multiply. What is it? Probability of Bi into probability of A given Bi. Where here I varies from 1 to 3. Sorry. Is that clear? Clear or not? You also can write the formula, sir. It's not a big deal. Generally people worry about the formulas. See, being a mathematician, I like formula. It is fixed, no? I don't have to change anything. Maybe notations I may change. Instead of Bi, I may use Ki. Something like that. So formulas are easier because they are fixed. Same question. Now comes the interesting part, that is Bayes theorem. And Bayes theorem gives you future probabilities. It gives you future probabilities, posterior probabilities. It gives you posterior probabilities. It gives you future. See, actually the Bayes theorem is one of the important results which is used for prediction purposes, pattern recognition and many real world applications where you do pattern recognitions or prediction purposes. We use Bayes theorem as one of the important results, my dear friends. That is application. Now look here, sir. Same story now, so I will not waste my time in explaining the story. We are having student, either he knows it or he gets the correct answer. And probability of getting correct answer when he know it, probability of getting correct answer when he gets it. This is all given to you. So here it is 3 by 5 and it is 2 by 5. It is being 1 and it is being 1 by 4. Now look here. See this situation. It's very interesting. I am not worried about answer, Mr. Mukhopadhyay. Very good. Your answer is 100% correct. But I am doing much better than that. Before going for examination, these are the probabilities. How much you know, how much you are going to guess. You return the examination. So you can see the C given K and C given G as probabilities at the time of examination. Once exam is done, nothing in your hands. Once exam is done, nothing in your hands. Correct or not? Is there anything in your hands? No. It is given to your faculty. It's given to your faculty. Now look here. You all know how much faculty believes the students. Now look here. I am faculty. I got a paper. I am correcting it. A particular answer is correct. A particular answer is correct. Now I want to know whether Lalit Yadav knows this or he guessed it. Lalit Yadav knows it, yeah, he guessed it. This is about future. This is about future. After the examination, that probability I am finding it. Given the answer is correct, the answer is correct. I want to know whether you know it or you guessed it. Given the answer is correct, answer is correct. I want to know whether you know it or you guessed it. And this is what we call it as future probabilities or posterior probabilities. Posterior probabilities or future probabilities. And Bayes theorem just gives the formula for this. Posterior probability formula, Bayes theorem. And for that you don't have to do anything, sir. Given that student given the correct answer, what is the probability that he knows it? I want to know whether you know it or not. This happens after the examination or before the examination? It happens in the future or in the present? Does it happen in the future or present? When it is happening, sir? Babu? Future. So we are finding future probabilities. And see, two important results we should know. One is called conditional probability formula. Probability of A given B is probability of A intersection B by probability of B. And similarly, probability of B given A is probability of A intersection B by probability of A. Actually, from this we get one more interesting result which is known as multiplication theorem. What is it called? Multiplication theorem. That is probability of A intersection B, I can get it. See, what is probability of A intersection B from second rule, sir? From this second rule, what is probability of A intersection B? It is simply probability of A into probability of B when A is already happened. And here, you need first formula or second formula? You need first formula or second formula? Which formula you require? For this future probability, we require first formula or second formula? For future probability, you require first formula or second formula? First formula we require, sir, because K given C means conditional probability. What is conditional probability, my dear friend? K given C, A given B. What is the formula? Probability of K intersection C by probability of C. And the denominator is total probability. Denominator is what, sir? What is denominator? Denominator is total probability. You remember, this is what it is. Denominator is what? PC. Denominator is PC. Correct or not? So, denominator is PC. So, what is it, sir? Denominator is simply, when you write this tree diagram now, denominator it is 3 by 5, 2 by 5, it is 1 and it is 1 by 4. Denominator is what? 3 by 5 into 1 plus 2 by 5 into 1 by 4. And what is numerator? Numerator is intersection. Intersection means corresponding probabilities for K and C given K. That is, for this 3 by 5, 1 into 1. Done. The problem is done. And that is your future probability, my dear friends. That is your future probability, my dear friends. I think you can solve this now. 3 by 5 and 7 by 10, which is nothing but 3 by 7 into 10 by 5, which is nothing but 6 by 7. And you can also answer the next question. See, probability that the answer is correct, I want to know what is the, given that the answer is correct, I want to know what is the probability that you guessed it. I want to know what is the probability that you guessed it. See, formula part from this multiplication theorem and this formula for conditional probability, you will get it. Okay, conditional probability, because K given C, is it same like this? Is it same like this? K given C is what? Intersection divided by probability of denominator. That is what I am doing, my dear friends. See, don't worry if you don't understand formula for time being. You understand the pattern now, that would be sufficient. And here, G given C means just corresponding probabilities you multiply. And in the numerator, corresponding probabilities of these two, that is 2 by 5 into 1 by 4 you put. negative alpha. That is the point to be noted for Bayes theorem. Why it is called future probability? That if you understand, this is a conditional probability. The entire game is from conditional probability onwards. This entire game, conditional probability, multiplication theorem, total probability, Bayes theorem, that is all story about conditional probability only. Sorry, conditional probability. Very good. Thank you. You understood. Is the idea clear? Any doubts? Now I solve this problem, and you can also solve this problem very easily, and I give you a small variant of this. I have one more class after this, but let me complete this problem. And look here, sir. The problem is simple. An automatic plant contracted to buy shock absorber from two suppliers X and Y. Am I clear? X supplies 60%, Y supplies 40% of the shock absorbers. Am I clear? All shock absorbers are subjected to a quality test. The ones that pass the test, there is some printing mistake. The ones that pass the test, the quality test, are considered to be reliable. See, here we are having an automatic plant where, okay, they taken contract from two suppliers. So here there are two suppliers. One is, okay, let me clear this. Okay, let me put this one. There are two suppliers. One is X and one is Y. X supplies 60% of the shock absorbers. Y supplies 40% of the shock absorbers. Now look here, this is very interesting. All shock absorbers are subjected to a quality test. That is, once you purchase, you apply some quality test on that. The ones that pass the test are considered to be reliable. So the ones which pass that particular test, whatever test you conduct, that are reliable. Of X shock absorber, 96% are reliable. That is, following these two events, there is one more event which is happening, that is reliability of that component. Reliability of that particular component. See, 96% supplied by X are reliable, 72% supplied by Y are reliable. Now the question is, probability that a randomly chosen shock absorber which is found to be reliable is made by Y. So this is simple story, sir. Either you are taking it from X or you are taking it from Y. 60% you are taking it from X supplier, 40% you are taking from Y supplier. Now they are subjected to test, and the ones which are supplied by X, how many are reliable? 90%, 96% of the shock absorbers supplied by X are being reliable. That is, it is supplied by X. What is the probability that it is reliable? 96%. Supplied by Y, and probability that it is reliable is 72%. Reliable given Y is 72%. That is 0.7. Now once it is given, you properly written priori probabilities and likelihoods, you can answer any question. Now what is that he is asking? A randomly chosen shock absorber is found to be reliable. You selected one shock absorber and you found that it is reliable. It is future event. So you found a shock absorber being reliable. You found that, let me write here. You found that a shock absorber is reliable. What is the probability that it is supplied by Y? So what I told you, whenever you write this corresponding probabilities, denominator is total probabilities, just 0.6 into 0.96 plus 0.4 into 0.72. And in the numerator, corresponding probabilities for, Y and reliable given Y, that is 0.4 into 0.7. And that would be the required answer, my dear friend. That would be the required answer, my dear friends. So what I want is, I'll give you one problem. I want you to give the answer in comment box, those who understood this concept, and I'll give you a hint for this. I want you to write the answer for this in the comment box. The probability that a randomly selected or chosen shock absorber which is not reliable is made by X. This is the second type of variant which you can get from Bayes theorem. First variant is straightforward, sir. He can ask you total probability, that is probability that it is reliable, or he can ask you probability of Y given R or probability that X given R, which is straightforward. The second type of question is what I asked here. Now, okay, let me give you the hint for this. Problem. With this I am going to conclude. This is very important variant. Many times in GATE they ask this question. Variant. See, actually, reliable given X and reliable given Y, you know it. But the question is not about reliable. It's about not reliable. So, in such problems, what we do is, you create this new table, my dear friends. I'll just erase it and write it here so that I get some space. Reliable given Y is there, no? So what you do is you write down this reliable given, not reliable given Y, not reliable given X. These probabilities you find, my dear friends. These are already known. Now you find these new probabilities. And you know, reliable given X is 0.96 means not reliable given X would be what? What is the answer for this? What is this answer, my dear friend? What is the answer for this? What is the answer for this and what is the answer for this? No, don't write like Rx whole complement. Don't write Rx whole complement, that is wrong. R complement given X you should write, which is 0.04. Don't write like this, my dear friend, this is wrong. Write it like this only. And what about this? 0.72 means it is 0.28. Yes, Lalitya. And from this you will get the answer for this problem, my dear friends. And this is the second variant which they regularly ask in GATE examination. Please remember. So those who understand these variants, you can see any of your previous GATE questions. It is one of them. And there is one more variant which they ask this followed by this. That is, two fellows contradict each other. That is, this one and this one, that combination also they can ask you. So those who understand this particular diagram, you can get all possible GATE questions, my dear friend. Nothing will go beyond this. You can take any GATE questions, will come under this categories. Any GATE question. Now, for this you are going to take, 10-hour sessions, 1-hour session, half-an-hour session, it depends on you. Those who can apply this can solve any problem. Means any problem should come under one of these categories only. Okay? If you understand this, you can solve any problem. If you don't understand this, you solve 1,000 problems, you require 1,000 more problems. That's it. Okay? So that is about Bayes theorem, my dear friends. I given the complete idea of Bayes theorem now. On Monday, I start with random variable idea. Even there, I'll give you the simple idea, my dear friend. I'm not going to complete it, but it is enough if you can apply. Thank you. Please write, okay, about this in comment section, how you like it, so that, and you also share this if you feel that it helps people. Okay, otherwise don't share it, don't tell anyone.